Today I'll be going over primary hemostasis, which is the initial response to a blood vessel injury or a disruption to the blood vessel wall. So what's going to happen is when you have that disruption to the blood vessel wall, your body is going to try to decrease that blood flow and at the same time produce some clotting components to help seal the wound. Very quick before we go over the primary hemostasis, it's important to know the anatomy of the blood vessels just so you can get an overall picture of what's happening. So you have the outer layer, which is your tunica adventitia, your middle layer, which is your tunica media, and your inner layer, which is tunica intima. Now, the most important thing to focus on is the endothelium, which is like the covering, the inside covering of that blood vessel. So when you have a disruption to the blood vessel wall, it's going to expose another layer kind of adjacent to the endothelium called the subendothelium. And that is where it's going to release the clotting factors, the components, and so forth. Just briefly looking over the four major components that occurs during the hemostasis, you have your rapid vasoconstriction. It's going to reduce the blood flow. You don't want to keep losing all that blood. The second part, you have your platelet adhesion. The exposure of that subendothelium layer is going to expose the collagen fibers, and that's going to attract the platelets and then aggregate them. The third part is your coagulation. And then lastly, you have your fibrinolysis. It's going to clean up the site and reestablish vascular integrity. So the first part of your primary hemostasis is vasoconstriction. So I'll do a quick little sketch of the blood vessel. So here we have the endothelium layer is the red single layer cells, and then on the adjacent membranes you've got the subendothelium. And then over here, you can see the blue fiber. Those are your collagen fibers, and those are going to be exposed when the subendothelium layer is damaged or disrupted. Two different ways vasoconstriction can occur. You can have a nerve reflex, where it just kind of send an impulse down the blood vessel wall in response to injury, or you can have a release of endothelin 1 that is released from damaged endothelial cells. Is going to act on that smooth muscle and cause it to constrict. The next step to primary hemostasis is platelet adhesion. So this is going to be the start of something we are going to create called platelet plug, and that's going to help seal that wound. So we're going to want to bring that platelet in to the site of injury. So what we're going to see here is we're going to see a release of von Willebrand factor. So I have it in a triangle shape. That's not really how they look, but it's just to help visualize. You can kind of see what's going on. So that's going to help attract the platelets down to the site of injury. So von Willebrand factor can come from, just kind of floating around the bloodstream, or it can be released from that damaged subendothelial layer. And so then the von Willebrand factors are going to attach themselves to the collagen fibers. Next, the platelets will come down and bind to the von Willebrand. There's a couple different receptors on the platelets. You have the glycoprotein 1b and your glycoprotein 2b3a. That is an inactive receptor, but I'll explain more later in this video. So you're going to have the binding of the glycoprotein 1b receptor to the von Willebrand. Once that binding occurs, it's going to activate your platelets and induce a shape change. So we've finished our adhesion stage. Now we're moving on to the activation of platelets. So there's going to be three different things that's going to be happening during this activation. We're going to have a shape change. So what's going to happen is you're going to create those pseudopods, like those little arms or, little extended figures from the platelets. That's going to kind of expose the GP2B3A receptor. It's going to activate it. Then you're going to have your secretion of granules or degranulations. Your platelets have multiple kinds of granules, but I'm just going to be focusing on a couple main ones that are essential for primary hemostasis. You have your alpha granules, and you have your dense granules. Alpha granules is going to release bond Willebrand factor. That's going to help bring more platelets in. It's also going to release fibrinogen. That's going to promote aggregation of platelets. The dense granules is going to release ADP, which is used to attract more platelets. Also going to release calcium, which is essential for coagulation and also forming that bridge between fibrinogen and your platelet. That's going to be important in aggregation, and I'll get to that later. And lastly, your serotonin. That's also important for vasoconstriction. The last part to creating your platelet plug is the aggregating of platelet. So we have the adhesion of the platelet and we have the degranulation of the platelet. Now we want to start bringing in more platelets and start aggregating together to start forming this band-aid over that wound. So this process is going to happen in two different phases. You have your primary aggregation and your secondary aggregation. So you can see here we have the GP2B3A receptor right here coming off of that platelet. So we're going to start having the fibrinogen come in and bind itself to the receptor. Now, an important thing to make a note of, you also have your calcium that's going to come in and bind to the fibrinogen receptor. It's going to kind of solidify that binding. So this aggregation is kind of like a loose attachment. It's forming that first initial layer of the platelet plug. So this process is reversible. It lasts about 10 to 30 minutes. Then we have our secondary aggregation. So you still see, our initial platelet plug formation is kind of, still thin. It can be reversible. It can still easily break off. So we want to kind of solidify that, kind of make it stronger, form some sort of a fibrin mesh, kind of. So we're going to start with another granule that's released from your activated platelet. That's going to be called thromboxane A2. Thromboxane A2 is going to help recruit more platelets. It's going to help aggregate more and more and make that platelet plug a bit stronger. It's going to create a fibrin mesh over that wound. Now, the fibrinogen is going to convert to fibrin by other substances and agents such as tissue factors and thrombin, but those are for another day because that is part of the coagulation cascade. So that concludes primary hemostasis. So we have formed the platelet plug and we have stopped the bleeding, and now we can move on to coagulation cascade. But like I said, another video, another day.